So this is Chapter 8, Geometry as a Shape. So we're going to be talking about more geometry in the sense of building from points to lines to figures to three-dimensional figures. There are three sections in this chapter. The first one deals with the basics, what a point is, what an angle is. The second section deals with the different types of figures, and the third section deals with three-dimensional figures. Now, the way that these lectures are going to work is I'm going to go through, I'm going to read through the notes, talk about, hit the highlights, hit the good points. Um, and then for 8-1, I'm going to go to a certain point, and then when I get to that point, I'm going to stop and do an animated thing, or not animated, but where I'm going to have a camera watching me fill in and talk through some lecture notes over how to do the proofs. And I'm going to, so 8-1 will be two videos, 8-2 will be two videos, and 8-3 will be one video. Um, Again, I'll do it like I did for Chapter 7, where I put them all into a um, playlist for you to look at. So let's go ahead and get started. The first thing we're going to talk about is why this is important. Um, and there are 5 ways that we can think about size, shape, orientation, location, direction. Um, and one is eye-hand coordination, is being able to manipulate what you're doing and processing it with your hands and your eyes, and making a cone and making a cube or drawing a line with your hands. um, and you can't see me because I'm doing this as I'm talking and you can only hear me, so it's kind of funny. um, the next is how to identify a figure in a background, so a picture on a wall, how to identify a shape out of a cloud, that type of stuff. Next is the ability to recognize figures or objects when they're not in a familiar orientation. So, being able to see a cone, whether it's upside down, right side up, or sideways. Um, or being able to recognize an oval versus a circle and being able to tell the distortion in the two. Next is to find differences among objects that are the same. So, can you see the difference between a square and a rectangle, or a square and a trapezoid, or a square and a parallelogram? Things that are similar, but being able to find the differences and the similarities. Um, and the last thing is to be able to reproduce pictures when you aren't looking at the picture. So, doing it from memory. The first thing we're going to talk about that's really big in this section is point. A point has no dimension, it has no length or width, it's just a dot. But it does have a location, so it matters where the point is. As you can see, we have point P on the thing, on the page, and then we have point P with a bunch of lines going through it. One thing is that there are infinitely many lines that go through a point. But if I have 2 points, then those 2 points determine a straight line. So between any 2 points in a plane is a straight line. A line extends infinitely in both directions, in two directions. Um, how do we label a line? There are 4 ways. We can label this line as line L. Now that is a script L, and it is ELL. It looks like a script letter L. It is a special symbol in mathematics. We can also call this line the line AB. But notice that we have a line with arrows on both ends. We could call this BC, or we could call this AC. Collinear points are points that lie on the same line. If it is possible to draw a line between any 2 points, then they're collinear. Non-collinear means that you cannot draw a line between any 2 points. Um, Sorry about that. Um, a line segment is a subset of a line. It has a beginning point and an end point. We actually call them both endpoints. When you label a line segment, you must label it from the beginning point and the end point. So it could be the line segment AB or the line segment BA, but you cannot call it the line segment AC where C is between A and B. You have to do it from the beginning to the end. Whereas a line, you can do it from any points. It's the symbol above the letters that tell you whether it's a line segment, or a ray. A ray is another subset of a line. It goes from one endpoint on to infinity in the other direction. Okay. Two lines intersect if they have exactly one point in common. If two intersecting lines are at a right angle, they're said to be perpendicular. If three or more lines intersect at a point, then the lines are said to be concurrent lines, and that's important. It has to be three or more, not two, three. Two lines that lie in the same plane that never intersect are parallel lines. Two lines that do not intersect because they do not lie in the same plane are skew lines. In other words, skew lines cannot lie in the same plane. Two lines that are skew are not in the same plane. And there are pictures of all of them except for skew. The best way I have to describe skew lines, we'll look at in the homework where we'll have a cube and we'll talk about different lines on the cube and whether or not they're skew or not. A line that intersects two or more coplanar lines, and these are, now remember, lines that are in the same plane, they are either intersecting or they are parallel. Okay? They could be one or the other. They cannot be skew if they're in the same plane. But you're talking about two or more coplanar lines in different points is called a transversal. In other words, if I have two lines that are parallel and I have one line that intersects both of those lines, then that line is a transversal. A plane is considered to be a flat surface that extends infinitely in all directions. Note, it takes 3 points to define a plane. How many of you have ever sat in a desk that wobbles? The reason it wobbles is because between every 3 points there exists a plane. So when you add that fourth point to make a chair or the desk, that point doesn't necessarily have to be in the same plane as the other 3. And so that's why you get the wobbling in the desk, is because 3 points make a plane. 4 points can lie within the same plane, but for something that you're constructing, it's very hard to do that. When two or more points lie in the same plane, they're said to be coplanar. If they don't, they're non-coplanar. We typically name planes with capital letters, so either the 3 points or a capital letter, and we call it plane P or plane ABC. We use the word, there is not a specific symbol to mean plane. An angle consists of the union of two rays, so two rays that have a common endpoint, which is called the vertex. Each ray is the side of the angle. So let's scroll down just a little so we can see. And you have an exterior portion of the angle and an interior portion. You will denote which one you're looking at by the arc. So the angle measure that I'm looking for is what I'm denoting by the arc. We can name the angle 4 ways. We can name it angle A, and that's only if there are no other lines that come off of A. We can name it angle ABC, angle alpha, or angle 1. Now, you should note the angle symbol, it looks like a less than symbol, but the bottom part of that line is horizontal, and then it goes up. You could also put a little arc on it. I use half and half. It doesn't matter. Um, Here's another way to show how we do the angles, and I'll talk more about this last one that has the intersecting lines in just a minute. We'll have another picture of that in a minute. We typically, if we're going to use Greek letters, we use alpha, beta, and gamma to mean angles. I generally like to use numbers, but I do use alpha, beta, gamma. It just depends on what I'm doing. When we talk about rotations in Chapter 9, I tend to use alpha, beta, and gamma to denote the movement of the rotation and the angle measure there. But generally, I try to stick with numbers or A, B, and C. And again, I want you to notice these letters are all capital. Capital letters mean something in mathematics, and lowercase letters mean something in mathematics. When we're looking at angles and planes, we're talking about capital letters. When we talk about lines, we typically use lowercase letters. The measuring of an angle, to use your protractor to measure an angle, you will extend your rays so that they cover your protractor, so that they go all the way out to the distance of your protractors. Then you're going to put your base along one ray and line it up horizontally with one ray, and then the other ray will show you the degree. This angle happens to be 53 degrees. Now, because you're not seeing me visually do this, there is a website. It is called, I was going to bring up my web and put it right here and go and show you a little bit of the website. If I can get my browser to work, because I'm clicking, but it doesn't really want to go there. It's Math Open Reference. And so we'll talk about constructions, and I'll show some of that to you when we get there. Angles. So if I want to look at the definition of an angle or look at how to use a protractor, so you're going to line up your angle with the baseline, and then you're going to the second ray, so one ray is going to be lined up with the baseline, the other ray is going to show you which angle it is. And this is a great website to go and get other information. So you're looking at definitions of angles, what an acute angle is. It even has a little quiz to make sure that you understand what you're doing. But this is also going to be very important when we get into the next chapter, which is constructions. And so here you'll see that there's constructions. This also has a lot of different similar triangles and stuff that you can use for the proofs. So this is Math Open Reference. It's a great website for you to go and use as an additional resource. If you want to print graph paper, well, there you go. So now, when we talk about measuring angles, so we were measuring the inside angle of 53 degrees. And so what if we wanted to say, we're wanting to know what this reflex angle is. That's what this is called, the reflex angle that goes all the way around. Well, the way that I did it is I extended my ray, I matched my base angle up here, and I measured the 133 degrees. Then I subtracted 133 from 360, because 360 is how many degrees there are in a circle, and that's how I came up with 227. Now, we have 5 different types of triangles. I'm sorry, 5 different types of angles that we're going to talk about. The first is a right angle. A right angle is a 90-degree angle. An acute angle, which is an angle between 0 and 90 degrees. A straight angle, which is an angle whose measure is 180 degrees. An obtuse angle, which is an angle that is between 90 degrees and 180 degrees. And a reflex angle, which is an angle between 180 and 360 degrees. Now, let me say this. None of these are equal. So if I were writing this as an inequality, it would be 0 less than angle less than 90. If it is 90 degrees, it is a right angle. If it is 180 degrees, it is a straight angle. Adjacent angles are two angles that have one ray in common and they have the same vertex. Non-adjacent angles have nothing in common. Okay? Now, non-adjacent angles could have the same vertex, but they don't have to have the same. They don't have to have a ray in common, and those would be non-adjacent, but they share the same vertex. And we'll see an example. There's an example of that in the homework for WebAssign, I think. The sum of the measure of angles is 90 degrees, and those are two complementary angles. They do not have to be adjacent to be complementary. The sum of the measure of two angles is 180 degrees. They're supplementary angles. Again, they do not have to be adjacent to be supplementary. I should also note that notice that both of these definitions are two angles. Not three angles, but two angles are complementary. So you can only add two angles up and get 90 degrees to get complementary, or two angles up and get 180 degrees to get supplementary, not three. Vertical angles are, if I have two intersecting lines, the vertical angles are the ones that are across from each other. So angle 3 and angle 1 are vertical angles. Angle 2 and angle 4 are vertical angles. Note, vertical angles are congruent. That means that vertical angles have the same measure and the same shape. For this course, pretty much everything will have the same, that we will either be congruent or not congruent. But we don't run into a lot of stuff that doesn't have the same shape in this course. Two angles on the same side of a transversal with different vertices, one is exterior and one is interior, are called corresponding. So in this picture, 2 and 6 are corresponding angles, 1 and 5 are corresponding angles, 3 and 7, 4 and 8. Alternate interior angles are on the inside, so my interior angles are 3, 4, 5, and 6. Alternate interior angles are 4 and 6, and those are congruent. 3 and 5 are alternate interior angles, and they are congruent. Alternate exterior angles are on the outside of the parallel lines. So that's 1, 2, 8, and 7 are my exterior angles. 1 and 7 are congruent because they're alternate. 2 and 8 are congruent because they're alternate. Now, I'm going to stop right here for a minute, and I want to talk about opposite. Opposite in mathematics means to change the sign, or they're opposite sides of the transversal, so they're mirror images of each other. Okay? Alternate interior and alternate exterior are alternating across the transversals. Okay, so if you turn in when we get into proofs and you turn it in and it says these are opposite interior angles, you will not get credit. I do not know what you mean by that, because to me, opposite says to change the sign or to go across the line. And that doesn't make sense when you're talking about angles. I've also had students call vertical angle opposite angles. They're not, okay? So you need to be careful and make sure that you're using the correct terminology, okay? And there's a little note here that says I typically label clockwise. That's just how I do it. Notation, you need to know that congruence is equal bar with a squiggle over it, angle, line, ray, perpendicular, parallel, and line segment. You need to know all those symbols. Notes for proofs. And like I said, we're going to do proofs in the next video, but I'm going to still go over these notes right now. Imagine that I have two pair of parallel lines. So I have M and N are parallel and P and L are parallel. imagine that they're lines over a river. Okay? So if you're not on the line, then you are drowning because you're in the water. Okay? You can only go from point A to point C by going through B and D. Okay? You have to stay on the lines. If you get off the lines or jump across, you will drown. Okay? Next thing you need to note, when I put an M in front of the angle symbol, that means that I'm talking about the measure of the angle, so the actual degree of the angle. Versus when I use congruence, I'm talking about size and shape, and so I don't put that M there. So if I have congruence, I do not put the M in front of the angle. You will be marked off for this. The first statement in every proof should be your given. And I've already talked about not doing opposite things. Properties. You need to know 3 properties that we'll have for the proofs. One is the transitive property. What that means is that if A equals B and B equals C, then clearly A equals C. This also works for congruent. If A is congruent to B and B is congruent to C, then A is congruent to C. Reflexive means that A is congruent to itself. Substitution. For our case, substitution will only be used when we're talking about equal. So if I know that A equals B, then I can substitute B every time there's an A. And that's what that last statement says. Now, let's talk about examples. This is the first example. So there's a cube. This is the one that I was telling you about earlier. Here's a cube. Tell me 2 parallel line segments. Well, I've marked them all on the cube by arrows. So AB is congruent to DC, is congruent to HG, is congruent to EF. Okay? Those little arrows mean congruence. 2 line segments that do not lie in the same plane. So EH does not lie in the same plane as BF. Okay, those are actually skew lines. So if you look down at part E says 2 skew line segments. AE does not lie in the same plane as FG. 2 intersecting line segments, AB, AE. They intersect at the point A. 3 concurrent line segments, that means 3 line segments that intersect at one point, AB, AE, AD. Real easy. A pair of supplementary angles. This is a cube. All of the angles are 90 degrees. So angle EAD is supplementary to angle EHD. Those are both 90-degree angles. They are not, however, adjacent, but they are supplementary. A pair of perpendicular line segments. AB is perpendicular to AD. And are the points A, B, and G coplanar? Yes, because between any 3 points, there exists a plane. All right. Number 2. In the figure, AD and CF are perpendicular. So that means that angle ABC, angle DBE, angle CBD, angle ABE are all 90 degrees. Okay? Complementary angles are 2 angles that add up to be 90 degrees, whose sum is 90 degrees. So that's ABG, GBE. 2 supplementary angles are 2 angles whose sum is 180 degrees. So that would be BEG, GEF. Vertical angles, ABC, DBE. Adjacent angles, GBA, ABC. And I'm not going to, but I've got a whole list of them. A 5th grader says that 2 parallel lines are tilted the same amount. Is this correct? Yes or no? Two parallel lines have the same slope, therefore they are tilted the same amount, and that amount is the slope. Suppose that N is parallel to P. Example number 4. N is parallel to P, and then we have a transversal. Name two pair of vertical angles. Well, the vertical angles are 2 and 4, 1 and 3, 6 and 8, 5 and 7. Remember, I'm only looking at one intersection point. So where N intersects the transversal, and then I'm looking at where P intersects the transversal. Now for the next three, I'm looking at the parallel lines. So I want a pair of alternate interior angles. So the interior angles are 2, 3, 5, and 8. Alternate interior angles are 2 and 8, 5 and 3. Alternate exterior angles are 1, 4, 6, and 7. The ones that are congruent, the exterior angles are 1, 4, 6, and 7. Alternate exterior angles are 1 and 7, 4 and 6. Corresponding angles are on the same side of the transversal, and one has to be exterior and one is interior. So 1 and 5, 4 and 8, 2 and 6, 3 and 7. And adjacent, those are easy. 1, 2, 2, 3, 3, 4, 4, 1. Okay, now I am going to stop here, and I know I've already scrolled down and shown you the next page, which I was trying not to do. I'm going to stop here because the next page I really want you to see how we work through the question. So that is where I will pick up with the next lecture that is a video of me actually working the questions.